Hello and welcome back to this channel. Dear students, today's topic is reflection coefficient and SWR, that is standing wave ratio for the transmission line. Now earlier we have discussed the characteristic impedance which is denoted by Z0. There is one more term which we will denote it by ZR. Basically Z represents impedance. So Z0 is characteristic impedance. ZR is the impedance connected at the receiving end of the transmission line. Now, if at the receiving end is also known as the load end. If at the receiving end Z0 is connected, then there will be smooth flow from transmitter to the receiver. Let us say value of Z0 according to some calculation is 100 ohm. That means at the output end I need to connect impedance or resistance of 100 ohm. If suppose instead of connecting Z0, suppose I will connect some another value, let us say 50 ohm, then in that case the wave which is getting transmitted and reaching at the receiver will get reflected back. This is known as the reflected waveform. Why this is taking place? This is because we have designed that system should be terminated, means at the output of system 100 ohm should be connected, but if you are connecting some different impedance, that is 50 ohm, then incident wave means the wave transmitting from transmitter to the receiver gets reflected from the receiver, part of the wave is getting reflected back. This is the concept behind reflection coefficient. So the amount of wave which is getting reflected back, this is happening because we are not connecting Z0, we are connecting some another impedance, that is ZR. So that amount is measured in terms of reflection coefficient. Notation is K. Definition is pretty simple. It is the ratio of reflected voltage or current at the load or receiver to the incident voltage or current at the load. So in a simplified language, it is ratio of reflected voltage or current at the receiving end to incident voltage or current at the receiving end. Keep in mind, in case of transmission line, voltage is denoted by E and not by letter V. It is denoted by E, whereas current is denoted by normal notation, that is I. Now, the derivation starts with this equation. Actually, you don't have to derive this equation number 1. This derivation of reflection coefficient, presently we are calculating the value of reflection coefficient K. It starts with this equation, e to the base small r. As I said, E stands for voltage in transmission line. So e to the base small r represents reflected voltage, whereas this term e to the base capital R, E means voltage, R means receiving end. So this is the voltage at receiving end. ZR is the impedance which we are connecting at the output. Z0 is characteristics impedance which is supposed to connect at the output, which is ideal impedance, divided by 2 ZR into e raised to minus gamma s. Gamma is known as propagation constant and gamma is given as alpha plus j beta, where alpha is attenuation constant and beta is the phase shift. Now S is the notation which is measured, or S is the distance which is measured from receiving end. There are two notations in transmission line. One notation is X. This is the distance measured from transmitting end, whereas S is the distance measured from receiving end. What this formula indicates, we have to take ratio at the load, means we have to take ratio of voltage or current at the receiver. So as I said, S is the distance measured from the receiver. So at receiver, I will write it like this. At receiving end, S will be 0. Very simple, because S is the distance measured from the receiving end. So if you put S is equals to 0 in this equation, then you will get e raised to 0. E raised to 0 is 1. So I will get equation of ER as e to the base capital R ZR minus Z0 upon 2ZR. Say equation number 2. Now this is the equation of reflected wave. If I want to write equation of incident wave, you don't have to mug up this equation. Only you just have to remember this simple formula as far as this derivation is concerned. to write the equation of incident wave, keep in mind incident and reflected waves are opposite in direction. So very simple trick I will tell you. Wherever a minus sign is there, put a plus sign. So simple equation of EI, that is incident voltage, is ER ZR minus Z0. This becomes ZR plus 0. Originally there is a minus sign, so it becomes plus upon 2ZR into e raised to plus gamma s. What I said, simple trick. If you know the equation of reflected voltage, to calculate equation of incident voltage, just change the sign, make minus sign, convert minus sign into plus sign. That's it. So this is the equation of incident voltage. Now at load end, I will have to put S is equals to 0. Like the previous case, if you put S is equals to 0, this term becomes e raised to 0. E raised to 0 is 1. So I will get equation EI is equals to ER ZR plus Z0 upon 2ZR into e raised to 0. E raised to 0 becomes 1. Now this formula, this derivation is pretty simple. You just have to memorize this equation number 1. As per the definition of reflection coefficient, it is ratio of reflected voltage or current. Presently we are talking in terms of voltage. As I mentioned, E stands for voltage. So it is ratio of reflected voltage at the load to the incident voltage at the load. So I can write it like this: K is equals to, take the ratio of equation 2 and equation 4. That is ratio of ER upon EI. So I will be making use of equation 2 and equation 4. So this can be written as ER ZR minus Z0 upon 2ZR divided by equation 4. I need to write it like this: ER ZR plus Z0 upon 2ZR. Now remaining part is this 2ZR gets cancelled. Similarly ER and ER gets cancelled. So answer of K will be ZR minus Z0 upon ZR plus Z0. So this is the final equation of reflection coefficient. But this is not the end of derivation. You need to write the comment. You don't have to mug up the comment. I will tell you simple tricks how to write the comment. First comment, after completion of derivation, as I said, you need to mention the comments. First comment, if ZR is equals to Z0. Now, at the beginning itself I have mentioned, if ZR is 100 ohm, then if Z0 is 100 ohm, and if you are connecting some another impedance instead of 100, say you are connecting 50, that is denoted by ZR. But if your value of ZR is exactly equals to Z0, that means 100 ohm, let us say as an example, then from this equation, say I will give some equation number 5. From this equation I will get K is equals to 0. Very simple. In place of ZR I am putting Z0. Z0 minus Z0 becomes 0. 0 upon anything is 0. So K is equals to 0. That means there is no reflection. So this is the first comment or first conclusion. K is the reflection coefficient. So if K is 0, it indicates there is no reflection. Second comment, if ZR is equals to 0. Now ZR is the receiving end impedance. If ZR is equals to 0, that means impedance is 0. So there is no impedance connected. In such case, you will get K is equals to 0 minus Z0 upon 0 plus Z0. This answer will be minus 1, which can be written as 1 at an angle 180 degree. Do remember, minus 1 indicates 1 at an angle 180 degree. So reflection coefficient will be having value 1 and phase shift 180 degree. Do remember, value of reflection coefficient is ranging from 0 to 1. That is, minimum is 0, as we discussed in the first case. In the second case, when ZR is equals to 0, that means impedance is 0. So in that case, the value becomes 1 at an angle 180 degree. So reflection coefficient is 1, which is said to be a maximum reflection coefficient. Third case, if ZR is equals to infinity. In this case, you need to rearrange this equation. because ZR is equals to infinity. If you directly put in this equation, if you directly put value infinity, then it becomes infinity minus Z0, which is infinity upon infinity plus Z0, which is again infinity. So infinity upon infinity is meaningless. So I need to rearrange the equation. How to do it? Considering equation 5, I will divide numerator and denominator by ZR. So if you divide numerator and denominator by ZR, you will get 1 minus Z0 upon ZR divided by 1 plus Z0 upon ZR. Now what I said, I need to put ZR is equals to infinity. So this equation becomes 1 minus Z0 upon infinity divided by 1 plus Z0 upon infinity. Recall the identity, something upon infinity is 0. So Z0 upon infinity is 0. This Z0 upon infinity is also 0. So it is 1 minus 0 upon 1 plus 0. That means reflection coefficient is 1, which is the maximum value. So these two terms, ZR is equals to 0 and ZR is equals to infinity, indicates open circuit and short circuit conditions. I mean, if you write like this, ZR 0 and ZR is equals to infinity, then also it is fine. So in both the cases, you are getting reflection coefficient is 1, that is maximum value. So this was the third comment. Now last comment, as we discussed while deriving the value of K in all the three conditions, that minimum value of reflection coefficient is 0 and maximum value of reflection coefficient is 1. So you can write the comment like this: the range of K is from 0 to 1. This is about the derivation of reflection coefficient. The next derivation is standing wave ratio. It is abbreviated as SWR. What we discussed, if at the output Z0 is not connected, some other impedance is connected, reflection of wave takes place. If, see, incident wave is in one direction from transmitter to the receiver, whereas reflected wave is in opposite direction, that is from receiver end to the transmitter end. If both the waves are having equal amplitude, they are same, then the wave will not propagate. This concept is known as standing wave ratio, denoted by SWR. Mathematically, the formula for standing wave ratio SWR is ratio of mod of E max. Keep in mind, E is voltage, so magnitude of maximum voltage to the magnitude of minimum voltage. Now, as I mentioned, E stands for voltage. How maximum voltage is obtained? Very simple. There are two waves, incident wave and reflected wave. If both the waves are in phase, that means they will get added and maximum voltage is obtained. In another language, if both the waves are in opposite phase, then waves will be subtracted and you will get the minimum voltage. So I can simply write this as mod of E max, that means maximum voltage, is obtained when incident and reflected wave are in phase and they are getting added. So mod of EI plus mod of ER. Similarly, minimum voltage is obtained when incident wave and reflected wave voltage get subtracted because they will be in opposite phase. So this is the equation to calculate mod of E min. Now put these values in, this is say equation number 1. Put these values in equation 1. So you will get SWR is equals to mod of EI plus mod of ER upon mod of EI minus mod of ER. Just now we discussed one formula. Reflection coefficient K is a ratio ER upon EI. I want to obtain equation of SWR in terms of K. So to rearrange the equation, I will divide numerator and denominator by mod of EI. So you will get SWR is equals to, if I will divide numerator and denominator by mod of EI, first term becomes 1 plus mod of ER upon mod of EI divided by 1 minus mod of ER upon mod of EI. What do we discussed? ER upon EI stands for K. So I will write this equation as SWR is equals to 1 plus mod K divided by 1 minus mod K. This is the equation of standing wave ratio in terms of reflection coefficient, that is K. Now, we will solve few numericals to get an idea how to use this set of formulae. The problem is transmission line has characteristic impedance of 50 ohm. This given value of 50 ohm, the notation is Z0. Find reflection coefficient if line is terminated with, these are 4 different values which are given in the question. So first part, these given values, I mean it is clearly mentioned, find reflection coefficient if line is terminated with, means these are the given values for ZR. So for first part, ZR is equals to 50 ohm. We are supposed to calculate value of K. The formula of K is ZR minus Z0 upon ZR plus Z0. So for first part, ZR is 50 ohm, Z0 is already given as 50. So I will write 50 minus 50 upon 50 ohm plus 50 ohm. 50 minus 50 is 0, 0 upon 100 is 0. So answer of first part, reflection coefficient is 0. You can well write this is the condition for getting minimum reflection. Second part, given ZR is equals to 0. Again make use of the same formula. I am using same formula. ZR is 0, so it becomes 0 minus Z0 is 50 upon 0 plus 50. So answer is minus 1. Whenever you are getting minus 1 answer in reflection coefficient, be habituated of writing it like this, 1 at an angle 180 degree. You can well write this indicates the maximum value of reflection coefficient. Third condition, ZR is given as 75 plus J75 ohm. Again I am making use of same formula, this formula. So put the value of ZR 75 plus J75, this is value of ZR, minus 50. 50 is the value of Z0 upon 75 plus J75 plus 50. So this becomes 25 plus J75 upon 125 plus J75. Now you are supposed to convert it into polar form, numerator term, then convert denominator into polar form and then do the calculation, or you can well use the calculator in complex mode. Do watch that video in which I have explained all such type of calculations. So presently I will perform the calculations on the calculator. So this answer will be 0.54 at an angle 40.6 degrees. Fourth part, ZR is, it is very much similar to the third part, only values are different, J40 ohm. So as I mentioned, just put the value of ZR in this formula. Instead of 75 plus J75, you will be putting 75 plus J40, remaining all the things will be same. So K will be 25 plus J40 upon 125 plus J40. So if you solve this on the calculator, answer will be 0.35 at an angle 40.25 degree. So these numericals are pretty simple. You just have to make use of only one formula. Now let us solve one numerical related to SWR. The next numerical is transmission line has characteristic impedance of 692 at an angle minus 12 degrees. This is the given value of Z0 and is terminated into load impedance of 200 ohm. This is the value of ZR. Determine reflection coefficient, that is you need to determine value of K and SWR, standing wave ratio. We have to just make use of these two simple formulae. First, to calculate value of reflection coefficient, I will be making use of first formula. So K is equals to ZR minus Z0 upon ZR plus Z0. Simply you have to put the values. So ZR is 200 minus Z0. this value is given in the polar form. If you are performing addition or subtraction, you need to convert this given value into the rectangular form. Once again, I have already created the video how to make this conversion. Do watch that video. So presently I am directly converting it into the rectangular form. So after conversion, this value will become 676.88 minus J 143.88. This is the value of 692 at an angle minus 12 degree in the rectangular form. This minus sign I have kept it as it is, divided by ZR is 200 plus value of Z0 remains as it is 6.88 plus J. This is ZR plus Z0. So value of Z0 is minus J 143.88. So you just have to simplify these calculations on the calculator. So you will get the answer of K, that is equals to 0.56 at an angle 172.52 degrees. This is the answer of K. This magnitude and angle is 172.52 degree after solving this on the calculator. Now, second part is SWR. I have this formula to calculate SWR. So I will write the formula 1 plus mod K divided by 1 minus mod K. Now, a common mistake. In the formula, I have magnitude of K. This is the answer of K. In this 0.56 represents magnitude of K. That is, this value is denoted by mod K, whereas remaining part is the angle. So I have to put the value of magnitude only. So I will put it like this: 1 plus 0.56 divided by 1 minus 0.56. A simple calculation. So answer of SWR will be 3.545. It is the ratio, so it is unitless quantity. So this is the final answer. Dear students, that's it for today's video. I have told you that these numericals are based only on this simple two formulae. So thanks for watching this video. Thank you very much.